Alright guys, let's try black. We're going to look at 1415. The reason I chose this is because it has multiple particles in our system. So here we have a system where we don't only have one particle, but a system of particles. So how do we go about solving this kind of problem? By the way, there's an example of this. Example 14.6, you need to go check that out. Do every single example in the textbook, guys. Go through every bit of theory. Do as many problems as you can. Yeah, that's the way you should do it. So here we have a cylinder A. This is 3 kilograms. Cylinder B is 8 kilograms. It says determine the speed of A after it has moved 2 meters. Okay? So delta SA is 2 meters. So that's the displacement of A is 2 meters starting from rest. Neglect the mass of the cord and pulleys. Okay, so we need to determine the speed of A. So we need to determine what is VA. Alright? So that's the basic rundown. So what you could do in chapter 13, you could analyze each of these particles independently, do a free body diagram of both of these. You can go look at there's an example in chapter 13 using the principle of force and acceleration. But now we're using the principle of work and energy, and you can also isolate each of these particles and carry out the principle of work and energy for both of these. Okay, but we can eliminate these internal forces, the internal tension in the system, by considering effectively that as our system. That is our system. And inside of our system, we have these two moving particles. And what are the external forces on the system? We have tension here, right? That's the tension from the fixed support over here. And we've got weight of B, and we've got weight of A. Remember, you define your system, okay? These are our two particles, and then we need to consider what are all the external forces acting on the system, okay? So we've got tension here, right? Tension is acting on this particle. There is tension here acting on block A, but they're internal to the system now, okay? So the work done by the tension will just cancel out. Okay, so let's come back here. So we've got the sum of the kinetic energy at state 1 plus the sum of all the work done on all the particles by the forces from state 1 to 2 is equal to the sum of all the kinetic energy of all the particles at state 2. Okay, we've got 2 particles. So it says here, determine the speed after it has moved from rest. Okay, so our kinetic energy at state 1 is going to be 0 because the velocities of A and B are 0. So you've got 0 for block A, kinetic energy, and 0 for block B. But now we need to consider this tension at the top over here does no work. Alright, because it's a fixed point, nothing is moving over here. Whereas the weights do work. They both do work because these blocks are moving, okay? So, even though we've got 3 forces acting on our system, this force does no work, these 2 forces do work. And what we're going to do is we're going to assume down as positive. Okay, you'll see a bit later how we do that, or why we do that. So, if the weight is acting downwards in both, we will have the weight of A, let's look at A, times what? Remember, the work of a weight is W delta Y. Okay, but because we're working with S position of A, we're just going to say delta SA. Okay? So, if block A is moving down, our assumption, guys, our assumption here is that both of these blocks are moving down. Okay? Which means that the final position of A will be lower than the initial position of A. So delta SA is your S final minus your S initial. So if it's lower afterwards than before, this is going to be negative, right? This will be negative. And W, well, let's just put it this way. Both of these vectors will be in the same direction. So the work done by the weight will be positive. And similarly, if we assume that block B is moving down, then we're going to have positive work done by the weight B. Okay? All right. Then we're going to have half MA VA squared plus half MB VB squared. All right. So guys, our assumption is that both of these are moving down, which means that the displacement vectors and the weight vectors are in the same direction, which means we're going to have positive work. Remember, it's an assumption now, okay? Because actually these two weights are different, so one will be moving up and one will be moving down most likely. Okay, so now what is the weight of A? Weight of A is simply 3 times 9.81 times delta SA, and then we have 8 times 9.81 delta SB equals half of 3, that's the mass of A, times the velocity of A squared, plus half of, by the way, this is all at state 2, okay? All of this is at state 2, so half of M, that's 8, and we have VB squared. This is all at state 2, okay? It's all at state 2, and all of this is at state 1. Alright, so in this equation here, you can see we've got delta SA, delta SB, VA, and VB, okay? But what do we have? We know that the speed of, determine the speed of A after it has moved 2 meters. So we know that delta SA is 2, so we've got this value over here. But still, we've got 1, 2, 3 unknowns, okay? So we're going to leave this equation for now. And now, what we can do is, we can go to our kinematic equations. Okay, our kinematic equations. And over here, we can see that if we take that as our datum, and we've got that as SA, and we've got that as SB, then we know that 2SA plus SB is the total length. But this is just referring to our position. If we perturb it, if we take a delta, right, the change in our position, then we're going to have 2 times delta SA plus delta SB is 0. Right, the change in my position, the total change, the total length doesn't change, but if I perturb it, I say what is the change in SA and SB, right? In a sense it's the derivative, but I'm not really taking this with respect to time. So then what I can see is that delta SB is the negative of 2 times delta SA. Okay? So what does this mean? This essentially means, we've seen this many times before, that if SA moves, say, 1 millimeter, then SB will move 2 times SA, but in the opposite direction. Okay, and we know that SA is 2, so delta SB, using this, it says minus 2 times 2 is minus 4 meters. Okay? By the way, what we've done here, I want you to take note here, and we'll see this a bit later. I have assumed that delta SA is moving 2 meters down in the positive direction. which means that based on the relationship between these two, delta SB is moving minus 4, which means it's moving up 4 meters. But the problem doesn't tell us that this block A is moving down 2 meters. It just says it's moving 2 meters. That's all it's saying to us. But I've made the assumption by putting a plus 2 in here that it's moving down. Okay, just take note of that. So now we've got this. Also, in exactly the same way, if we do a DDT, we will have exactly the same relationship. We will have VB is minus 2 VA. All right? It's exactly the same as this. We're just taking it with respect to time. Okay? So now you can see, if I come back to this equation, I can plug in all my unknowns. So let's see here. So I've got 3 times 9.81 times 2 plus 8 times 9.81, and then what is delta SB here? Delta SB we calculated to be minus 4. So this is minus 4, and then over here we're going to have 3 over 2. VA is what we are looking for, so we leave that VA squared, and then we put 4 in there, obviously. And what is VB? VB is minus 2 VA. So we're going to put minus 2 VA in there, and we're going to square it. Okay. Now, as you can see, we only have one unknown here, and if you do this whole calculation, what I ended up getting was minus 255.06 is equal to 17.5 VA squared. Now what is wrong with this? What's the problem here? The problem is that I'm looking for I'm going to square root. I'm going to do this. I'm going to do minus 255.06 over 17.5 equals VA squared. So this is clearly problematic because, well, you can take a square root of a negative value, but not in this case, okay? So the problem is that I assumed that block A was moving down in a positive direction, 2 meters, which means that block B would be moving minus 4 meters. So actually what's happening is that block A is moving up 2, so this needs to be a minus 2, and block B needs to be a plus 4. It needs to be moving down. If you swap those around and you give it the right direction of motion, then this becomes positive, and then VA, I'm not actually sure what the solution is. Let me see if I can find it. Let me just quickly do it. 255.06 divided by 17.5. I get VA squared is 14.57, and then VA is square root of that, and I get 3.8 meters per second. Okay? So I hope that helps, guys. Any questions? Give me a shout out, give me an email, send me an email. Cheers.